Okay, now we're ready for our last topic, which is a discussion of rainbows. And so this is going to pull together everything that we've been talking about. Reflection, and then refraction, and then how do atoms interact with light. So all of these topics are involved in the formation of a rainbow. So let's first discuss how does refraction work with a rainbow. And if, for example, let's make a piece of glass, and let's say that it's shaped like this. Okay, now let's pretend that light is coming in like this, and then it's going to hit the piece of glass. So this is the direction that the light would go in if this material was made of this material over here. It'd just go in a straight line. But we know that because of refraction, then what's going to happen is it's actually going to go in this direction like that. Okay, now if it went in this direction, and let's say it hits right here, which way would the light go? Okay, the light would straighten back out again, and it would go off in whatever this direction was. So whatever that direction is, the light would continue to go off in that direction. So this is what it would do. So instead of having a square one like this, what would happen if we took our piece of glass and we shaved it and we turned it into a triangle like that? What would be the difference? So the light would still be coming in like this. The light would still ricochet off, and so let's say it's going to go in that direction. But now notice that this boundary over here is different than this boundary over here. You see that it's pointing, it's in a different, making a different angle there. So what's going to happen is instead of the light going in this direction, when the light gets over to here, it's going to be bent again, and it's going to go off in this direction. So that's what, let's say it's the color blue. So that's what the color blue is going to do. I've been giving you the impression that all of the colors of the rainbow, or even for that matter, all of the colors of the electromagnetic spectrum, radio waves, infrared, ultraviolet, red, blue, green, I think I've been giving you the impression that all of these different waves would go in the same direction when it went through a piece of glass. That's not true. So the different colors of light, Roy G. Biv, so red, orange, yellow, green, blue, violet, each one of those different colors is going to interact with the atoms that makes up this piece of glass differently. And so do you remember that, for example, when we had a pendulum, okay, you have a pendulum and you pull it out and you let it go, it would go back and forth at a certain frequency. But if you had a pendulum that was longer, it would go at a different frequency. So that the frequency of this thing is being determined by the properties of the pendulum. So similarly, the properties of the atoms that make up this piece of glass are going to interact with different frequencies. And so we know that red has a longer wavelength and a shorter frequency than what blue does. So different colors of light in the electromagnetic spectrum have different frequencies. So that means that when these different frequencies interact with the piece of glass, some are going to be bent more than others. If they interact strongly with the atoms, they're going to be bent very much. If the light doesn't interact with the atoms, then it doesn't bend very much. So take a look. You got blue and then you got red. Look at the way that the blue is bending. So this could be the blue. And then look at the way that the red is bending. So the red comes in at exactly the same angle. So here's the red. It's making the same angle as the blue. But notice that when it goes through, evidently, it's not interacting as strongly with the atoms. So it does bend when it gets into this part right here, but not as much. And so again, when it comes out, it doesn't bend as much. All right, so now let's remember the Roy G. Biv thing. So that I'll put red over here. So we got red, orange, yellow, and then G, and then B. Notice that red is on one end of the spectrum and blue is on the other end of the spectrum. So where do you think yellow would be? Well, yellow would be somewhere in here. So that if this is white light that's coming in, white light is Roy G. Biv, and it goes through a prism. So that's what this triangle thing is. When white light goes through the prism, it's going to spread out into all of the rainbow colors. Now, glass acts like a prism, so does water, a water droplet. So now what we could do is, let's pretend that this is a water droplet over here, and you've got light that the sun is going to be over here, it's raining over here, you are in between. So look at the picture there. The sun's over here, you're here, the rain is over here. So you're looking in this direction at the rain. And so every water droplet is going to act like a little prism. So that light is going to come in, and then it's going to be bent because it's being refracted by the water. But then when it gets over to here and it hits this edge of the water droplet, it's going to be reflected, and so it's going to be going in this direction. And then when it gets over to here, it's going to be refracted again. And so what you're going to see is if this is white light that's coming in, it's going to spread it out into the rainbow of colors. So that's why when you look at a rainbow, you see Roy G. Biv. You are seeing the effect of millions and millions of water droplets, and each of those teeny tiny water droplets is acting like a prism. And what you're seeing is the combination of all of those water droplets put together. So then we've got this problem of why is a rainbow like this? So why does a rainbow make a bow in the sky? And so this one is very difficult to explain without props. So what I want you to do is go to the internet and go to Conceptual Physics, the rainbow, and watch it. So that guy on that picture there, that is Paul Hewitt. So that's the guy who wrote your textbook, and that's the guy who made a whole bunch of physics videos, and then it ballooned into a textbook, and then that ballooned into a chemistry textbook. And so he is the father of conceptual physics, conceptual chemistry, conceptual earth science, and so forth. So now that I've built him up, okay, now you can actually watch him in action, and he is going to show you why is a rainbow, why does it make a bow shape in the sky. Watch it. Okay, did you? All right, was that pretty interesting? I hope it was. So let's take a break, and then let's come back and take a quiz over what you have learned today.